6.4, parallel and perpendicular lines. Sal.
Parallel and perpendicular lines appear all the time in the world around you. Think of streets, wallpaper, railway tracks, and skyscrapers. Look around your classroom. Where can you see examples of parallel lines and perpendicular lines?
Okay, we got two important definitions here. You guys should already know about these, right? You heard of this, parallel and perpendicular, before?
Yeah.
Okay. So parallel lines, they're lines that run the same direction and never cross. Matching arrow symbols indicate that lines are parallel. Perpendicular lines, they're lines that intersect at right angles. Okay, a small box at the intersection of point indicates a 90-degree angle. What do you think the relationship of the slope might be on parallel lines? First of all, what is the slope of these two lines? Luca, right here? What's the slope?
0.
Yeah, 0. We don't need any units. We don't need any numbers. We know the slope of a horizontal line is 0. Okay? What about the slope of any two parallel lines? AJ?
They'd be the same.
Yeah, this M2 is going to be equal to M1. This is M1, this is M2. Parallel lines, the slope's going to be the same. Okay, that's where this is tying into. Okay, I imagine. Parallel, the slope of perpendicular lines. Any idea, guys? Tim?
Opposites of each other.
Close. Yeah, very close. They are kind of opposites, Justin.
Reciprocals.
Yes, negative reciprocals, in fact. So what that means is if this slope, your one slope of one line, let's say, is 2. So that slope looks like this. If here's our x-axis, that looks like that. Okay, that's a slope of 2. Okay? Now a line that's 90 degrees to that line, right? Here's my 90-degree angle. That's going to be, remember, it's just 2 is 2 over 1. The reciprocal, so 1 over 2.
Sir, can you move?
Yeah. 1 over 2. And negative reciprocal, so negative 1 over 2. So that would be the slope of this line. Okay? That's all it is. So whatever your slope, you flip the fraction. If it's a whole number, you put it over 1. Flip it, put a negative sign in front. Okay? I imagine we're going to get into that though. Let's see. How are the slopes of parallel and perpendicular lines related? Graph each set of lines on the same grid. Okay, that's going to take a while. Let's see. 2. How are the lines in each set in step 1 related geometrically? How are the equations related? All right. So you're going to have to trust me on this one. We could graph it out, but let's see. 2x minus 3y, 2x plus 1. So these graphs, I can tell you right away, they look like this. This has a slope of 2 and a y-intercept of negative 3. 1, 2, 3. It looks like this. Okay? This is the first one. The second one has the same slope but a y-intercept of 1. So it looks like this. Okay? You guys see that? The slope is 2 in both cases. And this dictates, as we know, the y-intercept. And finally, the last one has a y-intercept of negative 2, and it has the same slope. Okay? So that's what they would look like if we graphed all 3. This one now, again, all 3 have the same slope. It's negative 1/2. And one is plus 4, one is plus 2, and one is minus 1. So those are our y-intercepts, minus 1. Negative 1/2 looks like this. Plus 2, going to look like this. And finally, plus 4, going to look like this. Okay? So notice how this is 2 and this is negative 1/2. You notice something about these two lines, or these two graphs? Alvin?
Oh, the lines are parallel.
Yeah, all the lines are parallel, you're right, when they have the same slope. But what do you notice about the graphs, the two graphs, the difference between these lines and these lines? AJ?
It looks like if you would combine them, all the lines would be perpendicular.
Yes, see that? If I had to draw right through? Cool, eh? They're all 90 degrees, so we'll see that in a minute, I'm sure. How are the lines in each set in step 1 related geometrically? How are the equations related? So how are they related geometrically? They are parallel. It's just talking about the first part. Okay? How are they related in the equation? The m value is the same. Slope, right? Graph each pair of lines on the same grid. Use the same scale on both axes. If you are using a graphing calculator, press Z square. So now what they're doing is they're graphing both of these lines on the same grid. So you can imagine these lines are just going to come up here. How are the lines in each set in step 3 related geometrically? They're perpendicular. How are the equations related? One slope is the negative reciprocal of the other. Make sense? One slope is 2, negative reciprocal, flip the 2 over the 1 is 1/2, and put a negative. AJ.
Would it matter whatever your b value is?
Let's think about that. No, it wouldn't. No, because if it's drawn, see how this line, AJ, is perpendicular to this, and this, all with different b values? So it wouldn't. It's just, the b value just dictates where they cross. But it's still the same. Okay? How can you tell whether lines are parallel from their equations? How can you tell? Max?
When they don't cross. Like when they,
No, from their equations, not the graph.
oh, when their slope is the same and the first difference.
Perfect. Yes.
Minus if it's different.
When their slope is the same, when the m value is the same, yes. Luca, right up here in front. How can you tell whether lines are perpendicular from their equations?
When there's a negative reciprocal, the slope on the first equation.
Perfect. Exactly. Example. Slope of parallel and perpendicular lines. The equation of a line is y equals 3x minus 4. Give the slope of a parallel line. Adam, what's the slope of a parallel line of this equation?
Y equals 3x minus 2.
Sure. He gave me the whole equation of the line, but I was just looking for the slope. The slope is just going to be 3, right? A parallel line will have the same slope, 3. The equation of a line is this. Give the slope of a perpendicular line. Alex. So here's our slope, Alex. What's the slope of a perpendicular line to this line? Really? Come on, Alex. Listen. Joseph. Yeah. Yeah, you just flip it, Alex. You flip the numerator and denominator and put a negative sign, okay? Okay, Alex?
Yeah.
Finally, the key concepts, the slopes of parallel lines are the same. The slopes of perpendicular lines are negative reciprocals. That's it. Any questions? Yeah.
So you see how in 3B on investigate,
Yeah.
they start off with a negative reciprocal and then they go to a positive reciprocal. So when you're just switching the reciprocal, you just put in the opposite for both.
What about -1, which will make it positive?
Yes. Yeah, if you start off negative, then you put negative, negative, right? So it becomes positive, right? And it's the negative reciprocal. If it's positive, it's going to be negative. If it's negative, it's going to be positive, right? And you just flip the numerator and the denominator, okay? All right, that's it.